welcome back to the channel. In today's videos we are going to design a AHT20 temperature and humidity sensor breakout board completely from scratch using KiCad. We will start from datasheet, create the schematic design, the PCB layout and the final generate the manufacturing file. So let's get started. So what's the AHT20 sensor? So I just open the datasheet. So here is the datasheet is downloaded. Okay, so the AHT20 is a digital temperature and humidity sensor that communicates over the I2C communication. Okay, so I just show you. So there is a I2C communication as CL and SDA. So it's offer high accurate temperature measurement, high accuracy humidity measurement, low power consumption, small package size, simple two-wire communication. Because of this feature, it is commonly used in weather station, IoT device, smart home products, environmental monitoring, and battery powered application. So before designing any PCB, the first step is always reading the data sheet. So here is the data sheet, and from the data sheet we need to understand supply voltages. Okay, pin configuration, I2C communication pins, recommended capacitors, PCB layout recommendations. So never skip the data sheet because it's contain all the important hardware requirement. So here is the data sheet and we will see that it is 4.7 kilo ohm pull up resistance, and here is the note of the power. So voltage range of the host MCU to the sensor is 2.2 to 5.5 volt. So 5.5 volt is the maximum range of the voltage, 2.2 is the minimum voltage range. Okay, and here's a capacitor of 106 and 330 to 390 ohms resistance on VDD. Okay, so it is work as a low pass filter. Okay, and one more thing, that is the PCB design. Whenever you design this sensor using this sensor, so you need to create this hole. Because of this holes is helping to create to generate the accurate data of temperature and humidity. So let's start the designing process. Okay, so I just go there and open the schematic file. Okay, and I already add this library index KiCad. Okay, because of it is not generally added. So here is the sensor. Okay, we already know we need to put two resistance. Okay, so I go there and search R. Okay, R is here. I choose 0805, that is because of it is easily hand solderable. Okay, so I put here one resistance and I need to copy and paste again. Okay, I simply connect this wire. Okay, connect one more wire. Okay, both wire need to connect like this, and we need to connect this wire with VDD. Okay, so VDD is here. Okay, we need to connect one more resistance, that is 390 to 200. Let's see the data sheet. Data sheet recommend 330. So I just use 330 ohm. So I just put 330 R. Okay, so here is the value we got, that is 330. It is connected. Okay, and we need to put 4.7 kilo ohm resistance. Okay, that is 4.7 k. We need to put here also, that is 4.7 k. It is for renaming also, and this is the initial part of doing this. We need one more thing, that is ground. Provide the ground. Okay, GND. Okay, so I just need to connect. Okay, we need to put, I just put 100 farad capacitor, so write C. Okay, so I just want to go there, C is selected, and 0805, it is the package. Okay, so 0805 package I already selected, and we need to connect like this. Okay, and this is our VDD. So we just giving the name of this wire, so I just there, that is net labels, and VDD. So this is VDD, this is SCL, this is SGA. Okay, so all the naming is perfectly, we need to put the value, that is 100 small m nano farad. Okay, we just giving this value. So our schematic is ready. This is the breakout board, so we need to add breakout pins for connection. Okay, so I go there, I just write connectors. Okay, and we need at least 4 pin. Okay, and which type we need to select here also, that is 2.54 horizontal. Okay, so this one is good for us. Okay, we just need to label these wires. SCL, SDA, ground, and VDD. Okay, so everything is perfect. Okay, so you can take a screenshot if you want to create your own, and going to the update effect. So we are updating this file into the routing file. So we got all these things. Okay, so first of all, this is our connector side, this is our VDD. Okay, this is our resistance. Okay, so I will post these videos, and after that you get the output. Okay, after completing the routing and the placement and board of, means the border of the board and all those things, and putting some nets, wires, grounds properly, so this is the proper breakout board, and I will show you the 3D file